In this video, we're going to be looking at the derivative of sine inverse of x. So here's our fact that you want to memorize. The derivative of sine inverse of x is 1 over the square root of 1 minus x squared. You didn't think that was going to be it, huh? You probably thought the derivative should be the cosine inverse. I did when I first was learning this. Okay, so of course students want to know why. Why do I have a sine inverse and I get this funkiness over here? Okay, so I'm going to show you the proof of this. So the idea here is that I want to take the derivative, right, of y equals sine inverse of x. I want to take the derivative of this function. Okay, well, I don't really know how sine inverse works, but I do know how sine works. So using inverses, I know that this is the same thing as x equals the sine of y, right? In the last video, we saw that that's how this notation came about, was because of this notation. All right, so this I do know how to play with. So what we're going to do is we're going to take the derivative with respect to x. This is going to be implicit differentiation. So this guy will just be a 1. But this sine, the derivative of sine is cosine times dy dx. Okay. Now we're used to this with implicit differentiation. When I do implicit differentiation, I'm used to my answers being a mix of x's and y's. So here dy dx is equal to 1 over the cosine of y. Awesome. However, that's not going to suit me well if I want my answer in x's. It's like, my original's in x's, you should give me my answer back in x's. Okay, so here's how this is going to work. We're going to use right triangle trigonometry. So here the angle is y. So let's draw a right triangle. My angle is y. Okay. Some of you might be thinking, Jen, how'd you know what to put there? I could put it here or here. I just can't put it in the 90 degrees. Okay. All right, sine is opposite over hypotenuse. So this is saying the sine of y equals x over 1. So the opposite is x, the hypotenuse is 1. If I solve for this missing side, right, I'm going to get that it is equal to the square root of 1 minus x squared. Now, some of you may be thinking, should I write a plus or minus? We always think of length as positive, so no, we'll just write a positive root. Okay, so what then happens is that this is my missing side. All right, that's all fine and dandy, but where does that land us? Okay, well, what's cosine of y? Cosine of y on this picture would be adjacent over hypotenuse. So according to this, the cosine of y would be adjacent over hypotenuse. Okay, so I'm going to put that in for cosine y. So when I do that, I will get 1 over the square root of 1 minus x squared. Boom. That's my proof. Okay. I do not require you to do this proof for me, but I'm just showing you why we started off with the sine inverse and we ended up with roots. It's kind of weird. Okay. Now, fun fact. Not only do I want you to memorize this, but I want you to memorize what it looks like for chain rule. So what it would look like in chain rule is the following. d dx of sine inverse of u would be one over the square root of 1 minus u squared times u prime. Okay. So I'm saying that if they put other stuff inside the sine, we're going to put that stuff in for x in my formula and then tag it by a u prime. In the next video, we're going to see a couple examples, but here is the 2 facts that you need to know for the derivative of sine inverse. The original and how to use it with chain rule. All right, next video, we'll practice.